Today we're going to look at unit analysis. Unit analysis is a way to convert from one measurement to another measurement, and we use it in chemistry a lot. So let's take a look at our first equality here. We're talking about mass conversions here, by the way, and we're going to use these conversions in our quest to solve a number of molecules of caffeine for our project. So we're going to use the equality of 1 gram is equal to 1,000 milligrams. We use this equality because oftentimes in caffeinated drinks, they talk about milligrams of caffeine, and we're going to need those in grams to do our calculations over to molecules, which we'll be dealing with in a couple days. So let's talk about mass conversions here. We're going to use this equality here, so we're going to keep it right there. And I have an example here, and the example is calculate the number of grams in 75 milligrams. So we're going to set this problem up this way. The first thing we need to do is we need to identify our known quantity. And here is our known quantity. That's our known, 75 milligrams. The way I'm going to work this problem is I am going to draw a straight line like this, well, relatively straight, and I'm going to put my known quantity up here, 75 milligrams. And I'm going to draw a line just down like that. Now I need to look for my unknown quantity. What am I trying to find? So it says calculate the number of grams. So I'm looking for grams. So I'm going to write grams right here and leave myself a little room in front. And now I'm going to go to my equality. My equality up here is 1 gram. 1 gram is equal to 1,000 milligrams. So because we are looking at grams, I'm going to pick this side of the equality. 1 gram. Those two are tied together. Now I've just used up this side of the equality now, so I'm going to take my other side of the equality right here, and I'm going to write it on the bottom. 1,000 milligrams, just like that. And now this problem becomes we're going to multiply across the top, so 75 times 1, and then we're going to divide by the bottom, dividing by 1,000. So before we do that, let's cancel some units. We do have milligrams here as a numerator and a denominator, so they cancel. Milligrams are going to cancel. So our answer is going to be in grams, because that's what's left here. Now, let's go ahead and run this through a calculator. And so we have 75 multiplied by 1, which is of course 75, divided by 1,000, which gives us an answer of 0.075. Now, we're going to look at our known here really quickly, just double check one last thing. And our known has 2 sig figs. 2 sig figs in our known. So we're going to want to round our answer off to 2 sig figs. And we did say the rule that leading zeros do not count for sig figs. So we do have 2 sig figs. So this answer is actually okay. We'll leave it just like that. Okay. Let's look at one more sample problem here. It says calculate the number of milligrams in 525 grams. So the first thing we're going to do is, once again, identify our known. There's our known value. We're going to write a straight line. We're going to put 525 grams. And we're going to look for our unknown. What are we trying to find? Calculate the number of milligrams. Milligrams, there's our unknown. So I'm going to put milligrams right here. Okay, I'm going to go up to my equality, and the number tied with milligrams is 1,000. So I'm going to put 1,000 in front, just like that. And then I've used up that side of the equality. So now I'm going to put the other side of the equality, 1 gram, on the bottom. And now grams are going to cancel. Grams and grams cancel. And we're going to multiply straight across the top, and then we're going to divide by the bottom. So 525 times 100, or 1,000 rather, gives me 525,000, and we're going to have a unit. We're going to make sure we include our unit of milligrams. Now, this is 3 sig figs. That's 3 sig figs. And our answer currently is also in 3 sig figs, but we can clean it up a little bit. Let's go ahead and place this in scientific notation. There's a decimal right there at the end. So let's rewrite this as 5.25 times 10, and we moved it 1, 2, 3, 4, 5 places to the 5th milligrams. My rule of thumb is I tend to place things that are greater than 1,000 or lower than 1,000th in scientific notation. Otherwise, I'll just leave them alone. This one's got a lot of zeros on it, so I can go get rid of them. Okay, and so that's just an easy little way to convert from grams to milligrams, milligrams back, and it's going to be useful for us in our project.